Okay, so question 11 is, how many of the following four equations has a graph that does not pass through the origin? So, if a graph passes through the origin, then that means it passes through the point 0, 0. And so if we substitute y equals 0 and x equals 0 into an equation that passes through the origin, then we should not get a contradiction. So let's consider the first one. So 1. So y is equal to x to the power of 4 plus 1. If we substitute y equals 0 and x equals 0, we will get that 0 is equal to 0 to the power of 4 plus 1. And this means that we have the equation 0 is equal to 1. Clearly this is not possible, so y equals x to the power of 4 plus 1 does not pass through the origin. Now let's consider the second one. y is equal to x to the power of 4 plus x. Substituting y equals 0 and x equals 0, we get that 0 is equal to 0 to the power of 4 plus 0, which gives us 0 is equal to 0. So this one here does pass through the origin. Now let's consider 3. Y is equal to x to the power of 4 plus x squared. Doing the same thing, we see that 0 is equal to 0 to the power of 4 plus 0 squared. So the third one does. And doing the same for the fourth one, we get that 0 is equal to 0 to the power of 4 plus 0 to the power of 3. Clearly this is true, so the fourth one also passes through the origin. So the only one that does not pass through the origin is the first one, and so the answer is B. Okay, so the 12th question is, a regular tetrahedron is a polyhedron with 4 faces, each of which is an equilateral triangle as shown. A solid regular tetrahedron is cut into 2 pieces by a single plane cut. Which of the following could not be the shape of the section formed by the cut? So what this question is basically asking us to do is, say if we had a tetrahedron and we had a knife and we cut the tetrahedron in some way into 2 pieces, and what the question is asking us is to find out which of the following possibilities listed are not possible for the shape of the face formed by the cut. And if we think about it, a tetrahedron only has 4 equilateral faces. And so if we make a cut through the tetrahedron, well then the cut can only pass through a maximum of 4 of those faces. And so what this means is that the face formed by the cut, can only have at most 4 sides. And so clearly the answer to the question is A, because a pentagon has 5 sides, and this is not possible because the tetrahedron only has 4 faces. And you can see that each of the other possibilities can be created as follows. So a square, a rectangle, a trapezium, and a non-equilateral triangle. Okay, so question 13 is that the lines y equals x and y equals mx minus 4 intersect at the point P. What is the sum of the positive integer values of m for which the coordinates of P are also positive integers? So at the point at which the line y equals x and y equals mx minus 4 intersect, the y coordinates will be the same. And so x will equal mx minus 4. If we rearrange this equation, we can get x minus mx is equal to minus 4. And so x 1 minus m is equal to minus 4. And so x is equal to minus 4 divided by 1 minus m, which is equal to, if you times top and bottom by minus 1, 4 over m minus 1. Okay, so now we want x to be a positive integer. And for this to happen, well, clearly m minus 1, which is the bottom of the fraction, needs to be a factor of 4. Otherwise, if it's not, we are just going to get a fraction. So m minus 1 can be equal to 1, 2, or 4. And because we want x to be a positive integer, we will not include m minus 1 being equal to minus 1, minus 2, and minus 4. And so if m minus 1 is equal to 1, 2, and 4, that means m is equal to 2, 3, and 5. And so the sum of the possible values of m is 5 plus 3 plus 2, which is 10. And so the answer is E. Okay, so question 14 is that the following 12 integers are written in ascending order. The mean of these 12 integers is 7. What is the median? Okay, so we're told that the mean of the 12 integers is 7, and so that means that their sum divided by 12 is 7. And so 1 plus 3x plus 5y plus 8 plus 9 plus 11 is equal to 12 times 7, which comes out as 84. If we simplify this a bit, we will get that 3x plus 5y is equal to 55. Okay, now let's look at x. So we have 3x plus 5y is equal to 55. And because 55 and 5y are multiples of 5, and x and y are positive integers, that means that 3x must be a multiple of 5 also. But since 3 is not a multiple of 5, that means x is a multiple of 5. So now what we can do is we can start thinking about the different possible values of x. So x must be a multiple of 5. And we also know, because the list is in ascending order, x is greater than 1, but also less than 8. And the only multiple of 5 between 8 and 1 is 5. So we know that x must equal 5. And if we do this, we can then see that 5y plus 15 must equal 55. And so y is equal to 8. Okay, so now we know the value of x and y. And the median will be between the 6th and 7th integer. So 1, 2, 3, 4, 5, 6 will be between these two values here. And so because these two values are the same, because y and y are just both equal to 8, we know that the median must also be equal to 8. And so the answer is D. Okay, so question 15 is, a square is inscribed in a circle of radius 1. An isosceles triangle is inscribed in the square as shown. What is the ratio of the area of this triangle to the area of the shaded region? So what I am first going to do is to mark the center of the circle and the square, since they both have the same center. So the center will be about here, and we'll call that point O. Now what we are then going to do is join diagonally opposite corners of the square. So I'll join this corner here to this corner here. So the diagonal of the square should pass through the center of the circle, but in my drawing it hasn't, so just keep that in mind. And what you can see is that the diameter of the circle is equal to the diagonal of the square. And so if I call the length of the square L, this side will also be L, and the diagonal by Pythagoras' theorem will be equal to L squared plus L squared, and we square root that, and that will give us L root 2. And this is equal to the diameter of the circle, which is going to be 2, since this question tells us that its radius is 1. So what this means is that the length of the square is, so L is equal to 2 divided by root 2, which if we simplify this by rationalizing the denominator is the same as 2 root 2 divided by 2, which is equal to root 2. Okay, so we now know the length of each side of the square. Well, the triangle has area equal to half its base times its height. And we can see that this base is the same as the length of the rectangle, and its height is also equal to the length of the rectangle. And so the triangle has area, so T, which stands for triangle, its area is equal to root 2 times root 2 times a half, which is equal to 2 times a half, which is 1. Okay, so now we know the area of the triangle. The area of the shaded region is equal to the area of the circle minus the area of the square. Well, the area of the circle is pi r squared, so it will just be pi since the radius is 1. And the area of the square is equal to root 2 times root 2, and so is equal to 2. And so the area of the circle minus the area of the square is equal to pi minus 2. And since the area of the triangle is 1, the ratio that we desire is 1 to pi minus 2. And this corresponds to D.